So this is another example of one of those travel problems. So it's travel number 2. Chester rode his bike uphill 35 miles and then back downhill 2 miles per hour faster than uphill. If he took 2 hours longer uphill than downhill, what was the uphill rate? Okay, now I don't know the answer to the problem, but I'm going to set up a chart. And I could draw a picture of Chester riding his bike, but I won't. Okay, rate, time, distance. We know that Chester goes uphill and then he goes downhill. And those are the two situations that I talked about in another video where you have these two different things going on. All right, so when he's riding his bike uphill, he goes 35 miles. Okay, so that's the distance, 35. And then he goes back down the hill. Well, that distance is also going to be 35. And that was a sneaky thing in there, that the distances are the same. He's going up the hill and then down the hill. So, here's the hill. He's going up. There he is riding his bike up and then back down. Same distance. Okay. But when he goes downhill, he goes faster. He's going 2 miles an hour faster. So I'm going to say that his rate up is, we'll say x, and then downhill he's going faster, x plus 2. So 2 miles an hour faster. If it took 2 hours longer uphill than downhill, what was the uphill rate? Now here's the thing. The time is not equal, right? So there's different ways you could set this up. I'm going to do this. Let's say that this is the time it takes him to go uphill. So t sub up. And that equals distance over rate, which is 35 over x. Now let's do the same thing, only t down. Now you might be saying, why didn't you just put t for both of them? I can't this time because the time is not the same, okay? So the amount of time that it takes him to go down the hill is 35 over x plus 2. Now, which one takes him longer? It takes him longer to go uphill, right? It takes 2 hours longer to go uphill than downhill. So if these times, okay, let me think of it this way. 2 hours up, 2 hours down. I'm trying to come up with an equation, right? So who do I add the 2 hours to? It takes him longer to go uphill, right? So I'm going to add the 2 to that. So you might have to rewind it and think about that a little bit. Another way you could do it is you could subtract. You could take t up minus t down. The difference between the times is 2 hours, and it takes them longer to go uphill. But these are really just the same equation if you look at those, okay? Now, the subscripts might be bothering you, the up and the down, but remember the times are different, so I've got to distinguish them somehow. Okay, so I'm going to use this idea right here, I think. I'll use this one. Okay, so my uphill, that was 35 over x minus the downhill, which is 35 over x plus 2. And all of that has to equal 2. Okay, so I went with this subtraction case. I just had to pick. So x times x plus 2. I'll have to use the LCD. This is not a proportion. You can't just cross multiply. You don't have one fraction equaling another fraction. I should say rational expression. Okay, so think about taking that LCD times this. Well, then that's going to give me 35 times x plus 2, because the x's would cancel. Then I'm going to take that LCD times this. So it's going to be minus, that minus sign, minus 35 times x, because the x plus 2's are going to cancel. equals, and then I'm going to take the LCD right here times that 2, but nothing cancels, so it's 2 times x plus 2. Okay, now we work our magic. It's algebra. 35x plus 70 minus 35x, well that's interesting, equals 2x squared plus 4x. Okay, if I simplify, that was the distributing here. You can think about that more if you want. If I simplify the left, I get 70 equals 2x squared plus 4x. Now, I'm going to do a little trick here. I don't know if I've showed you this before. I think I have, but maybe not. Do you see how they're all divisible by 2? I'm going to make my numbers smaller and divide everything by 2. I'm allowed. I'm dividing both sides by 2. Okay? I just did the distributing. 35 equals x squared plus 2x. That's going to make my life just a little bit easier. Now, this is a quadratic equation, so I'm going to get the 35 on the other side. I've got to set it to 0. It's not linear this time. And then I'm going to try to factor. So I'm going to get x plus 7 and x minus 5. That's how it's going to factor. Now, if you use the ZPP, you would get x equals negative, whoops, we got too many equal signs there. You get x equals negative 7 here and x equals 5 here. But we were doing, x was what, his rate? And it's not going to be negative. So it's got to be the 5. All right, now what were we finding? We wanted to find what was the uphill rate. X was the uphill rate, so we found it. It's 5 miles an hour. So uphill, Chester goes 5 miles per hour on his bike. Downhill, he's going 7 miles an hour, but they didn't ask for that. They just asked for the uphill. All right. These are tricky, but the more you see them and the more you practice them, the easier it'll get.